So if you guys would take a minute and try number 3, the directions are up above. They just continued from before. It just says differentiate with, and let's differentiate with respect to the independent variable x in this case. So let's try to find h prime of x. Keep in mind, of course, this is a composite function, and so there will be a chain rule factor that shows up on this. But please do try number 3, right? Ready? Just in case maybe you didn't see this, does it make sense to you to do a brief rewrite before? Yeah. So it would be, if you did that, it would be h of x equals, and I really don't like that fraction for the exponent. I'd rather write it as e to the negative 3 times x to the negative 1. I think that'd be a wise move when you start to think about what that chain rule factor would look like. This would make it easier. So you could do a quotient rule, eventually get there. But I'd rather do power rule. So you got to keep in mind that all those old rules for composites apply right now. So this is the derivative of e to the, and we're just going to say e to the u, where u is just some function, right? In this case, the u would be negative 3 over x, right? So the derivative of e to the u is just e into times the chain.
What's the daily scoop?
So like I noticed here that you brought this thing out in the front, and you're like treating e almost like it's it's not that. Just like the derivative of cosine.
Missionary is over.
I want to see this card.
Addie's walking into the building right now.
Yeah, I know. We talked. She had to move a car or something. She had to move her car or something. Okay, so the keep in mind the derivative of e to the u is simply e to the u times whatever the chain rule factor would be. So for this one, I would write h prime of x equals e to the u. Then I got to multiply by the derivative of that inside, or the derivative of the exponent here. So it would go times, now I multiply by the chain rule factor would just be the derivative of negative 3x to negative 1. So that would be positive 3x to the negative 2. So again, I'll just remind you that d dx of e to the u equals e to the u times the chain rule factor, which would be du dx, or u prime. What do you guys think? Is that okay? So this is another one of those skills. Like in the first semester, you learned a pretty limited number of skills. You learned how to differentiate with power rule, trig functions, and that would be it, wouldn't it? Right? So you basically just had 2 techniques. Now we've built into that, there's a new one. We did derivative of natural log, right? That was a new skill. Derivative of e to the u, that's another new skill. Make sense? Okay, fair enough. So that's just sort of a check to see if you're getting this new skill. Do you have any questions on 3? Okay, so then number 4. Number 4 is a lovely question, because what that does is it takes your new skill that you're developing with e to the x and e to the u and all those lovely things, and then it drags in an application from way back, right? Like I said, an application from, oh gosh, like October-ish, mid-October, late October, something like that. And that is find the local min and local max of x e to the x. So this is where we continue to just like chew on it, right? Like you might have been good at this. Last semester you might have been not so good, you might have been medium, I don't know. We're going to keep chewing away at this, right? Keep trying to process it and improve. So I want you guys to give this a shot. I want to give you one hint though. What are your candidates for local min or max? Critical numbers, period, right? Only critical numbers. So your first goal here should be to find critical numbers for f of x. Critical numbers for f of x. Ready, go. It's a great question. It really brings in a lot of old skills. Gotten to. So remember the commentary was, you guys said your candidates for local min or max are going to be critical points. And so you got to find your derivative in order to find critical points. Did you all recognize, a lot of you did you guys recognize that that right there is a product? So if you're going to be finding a derivative of that, you have to use the product rule. Yeah. Thank you. So the product rule for this would look like this. F prime of x equals 1 d2 plus 2 d1. That make sense? d1 would just be 1. The chain rule factor would be 1.
Should we just try it?
Yeah. Discuss, try, think, explore, propose answers, fight about it. I don't know.
Let's get in a fight about it.
Take a few minutes and
Let's get in a fight about it.
math fights only, please. No kicking or hitting, please.
What about slapping? We just.
No slap.
That ain't gonna work. I mean,
Why would you say that?
Because the definition of the derivative, which is
Okay, so the definition of the derivative is that limit as h goes towards 0 of f of x plus h minus f of x all over h, and that's equal to f prime of x, right? Oh, frozen again. Sorry. Okay. Right?
yeah,
Okay. And so you're proposing an answer of e to the x
yeah,
because you think this is the definition of the derivative?
yeah.
Okay. What are you looking at? Like, why would you say that it's the derivative of e to the x? What are you seeing?
I see the minus f of x, and I see the minus e to the x. So I think the function is e to the x, because I know you have to
It's a pretty good hint.
differentiate it.
Yeah, pretty good hint. You can see that f of x plus h is also e to the, in this case, x plus h. Yeah. So what you would do here, Tim outlined it pretty well. You'd recognize, number one, it's the definition of the derivative. Number two, you'd recognize it's the definition of the derivative of e to the x. The final step is, do you know it? And if you do, then you would simply write equals e to the x. You're recognizing that's the definition of the derivative. Okay. I am greatly encouraged because I walked around. There was lots of positive talking and good answers, and that's pretty good. Pretty good. Okay, cool. Let's do a little skipping ahead. We're going to talk a little bit about integrals here. Again, this was part of your intro video. And just as you would imagine, if the derivative of e to the u du, or derivative of e to the u is just e to the u du, if you reverse that, you probably should just get e to the u plus c, right? Hopefully you got that from the intro video. Some of these can be a little trickier on the algebra side in getting these to a good form. I think a nice example of that would be numbers 4 and or 5 right there. So let's take a minute here, look at 4, and please, for goodness sake, realize that in order for this to feel doable, you're going to want to do some manipulation ahead of time, right? Do some algebra, get it into a better form, and I'm hoping that we've done enough of these to where you're kind of getting a sense of what I mean by better form, and see what you can do with it, finding an antiderivative of this. Ready to go. Hey guys, let's take a look at this one. At least let's look at how we should set this up. I think that it would be extremely helpful to rewrite this like this. E to the x to the negative 1. E to the x to the negative 1. If we can avoid having fractions, we're going to. And then that x squared, which was in the denominator overall for the integrand, I'm going to flip that up as well. It would be times x to the negative 2 dx. I was talking with some folks about this, and I just had a moment of clarity. I thought this would be good to share with you because I think sometimes it's good to see the big picture. You can see pretty clearly that this integrand right here is a product, right? It's some function times some other function. Over the course of our entire school year, first semester and second semester, we will learn exactly one way to deal with this. And that's the U substitution / Timmy messed up the chain rule routine. That's it. So if you see that your integrand is a product, you need to at least consider that, because that's the only thing we've learned, and that's the only thing we will learn in this. If you take like Calc 2 or Calc BC, you'll learn other ways. There's other scenarios where you have to have new methods, right? This, the only method we're really going to learn in this course. So with that in mind, the other question that came up is, cool, Mr. Anderson, I get the whole Timmy messed up the chain rule thing. What on earth is the inside function? Not as clear, right? What do you think? X to the negative 1. The exponent in these cases will always be the inside function. So maybe even put some parentheses around that to make that clear. That's your inside function. So then it comes down to this question. What's the derivative of the inside? Negative x and negative 2. Does that match the other factor? It's really close. What do we need to change to make it multiply by negative? So I'll just go times negative 1 times negative 1. Now I've got a perfect chain rule for e to the u inside. So here's what happens. That negative on the outside, it goes nowhere. But then what I'm going to circle in blue just disappears back to the inside. So this negative, this, and this, they all just disappear back into the place where they came from. And what's the antiderivative of e to the u du? E to the u, right? Easiest antiderivative of the year. The antiderivative of e to the u du is simply e to the u. So it would be the negative of e to the x to the negative 1 plus c. If you have any doubts about this, what could you do with your answer? Do a derivative. See if it matches the original integrand. And it will. It will. Okay, cool. So more algebraic manipulation ahead. Number 5. Give it a go. Number 5. E to the root x over root x. Sort of similar to number 4, so hopefully you'll be able to navigate through this one. Did you guys do that? I'm hoping you're developing this intuition about here's how I should manipulate this so that it's easier versus how can I make this difficult? We're going to make this easier on you. Okay, so then we ask the question, Timmy, did you mess up?
Heck yeah, I did.
Timmy totally messed up, but he's off by what factor? 1/2, right? The derivative of the inside, it would be 1/2. X to the negative 1/2. Does that make sense? So I do this, and now Timmy's mistake is fixed, but I have to adjust for that on the outside by doing what? Multiply by 2. So there's that. Okay, so now I've got this lovely e to the u du set up. What's the antiderivative of e to the u du? E to the u plus c, right? So this is just going back inside. This is just going back inside. So I end up with 2e to the x to the 1/2 plus c. Say again, Robbie? I multiply the inside by 1/2, so I've got to multiply the outside by 2. I see, so it's at this point, oh, you guys should probably hear this. It's at this point where I feel like you guys have seen this whole chain rule pattern thing a lot, and you're probably starting to get, if you're not already, you're starting to get pretty good at it. And there's going to be a temptation now for you to get lazy and just like write like one part of it. Like, I'll just do the outside part because I know what's going on the inside. I've seen so many people do that, and they end up screwing it up. They're like, oh, then they end up getting bad at it. They're like, do I multiply by 2 or do I multiply by 1/2? I can't remember. Just do both. Just go times 1/2 times 2 times 3 times 1/3. Write them both. You'll be okay, right? I mean, you're not wasting that much of your life by going times 1/2. Might not even be a whole second. Maybe half a second. Who knows? Guys, questions or concerns about that one? Okay, let's move on. Let's go to number 6. We're going to start doing some definite integrals now. Look at number 6, please. All right. Let's see how this turns out for you all. I need to give myself a little bit more room here, so I'm just going to do just a quick rewrite just for more space. This one's a little bit different. It's very simple looking, e to the negative x. Remember that in order for this to work, it's got to be e to the u du. So in other words, the derivative of the inside has got to be the other factor, right? So what's the derivative of the inside? Negative 1. And I don't see negative 1 anywhere in there in the integrand, right? It's positive 1 times e to the negative x. So I can fix this, right? This is just a Timmy mess things up. I'm just going to multiply by a negative 1 on the inside and a negative 1 on the outside. And I've got my perfect e to the u du set up. So this just goes back inside. This goes back inside. This continues. So it would be negative e to the negative x, evaluated from 0 to 1. And we just do FTC1. So this would be negative e to the negative 1 minus negative e to the 0. So we could clean this up a lot. I'm coming up with this. What's e to the 0 again? 1. So I kind of like this. That seems like a nice, tidy answer to me. Did I mess something up? What do you got, Ellie? Yeah, because you've got negative e to the negative x. So when I plug in the 1, the negative up front's still there. And then negative x is negative 1. Ellie, did you have it right and Tim talked you out of it? Mm-hmm. Oh.
Timmy messed up.
Well, so you could write it like this. You could write it like negative e to the negative 1 plus 1. That would be just as good. I just decided to flip my e to the negative 1 down.
I know, I'm just confused why it's negative c with fractions.
Oh, so when I look at this original integrand, in order for this to work out nicely, the chain rule pattern has to be there. The chain rule pattern is that the derivative of the inside is the other factor in the integrand. So the inside function is negative x. Like that's inside, it's the e to the whatever, it's e to the negative x. The derivative of that is negative 1, and negative 1 is not present as part of the integrand. So what I would do is I'd multiply the inside by negative 1, and to balance that out, I'd multiply the outside times negative 1. Does that make sense?
She had it right for the wrong reason, and I talked her out of it.
Okay.
But, yeah.
Okay, that's fair. That's a good discussion to have. Definitely a good discussion to have. And so, Ellie, that's what I've got going on over here with this negative and that negative. Does that make sense? Okay. Any other questions? Okay, then let's look at number 7. That's e to the x times cosine of x for your integrand. So again, please try this. Hoping you're starting to see this is a lot of Timmy messed up the chain rule. Just a different brand involving e to the whatever. So hopefully that consistency is good, right? We're still using the same line of thinking, it's just with a new type of function. Just the antiderivative, not the final answer or anything like that. Just to kind of be like step number 1. What do you think it would be? Go ahead, Luke. Sine of e to the x. And that's it? What do you guys think? Is that good, bad, it's close? You know how you could check this? Just do a derivative. What's the derivative of sine of e to the x? Wouldn't it be cosine of e to the x times the derivative of the inside? Oh, it worked, didn't it? It worked perfectly. So Luke's right. That's definitely our antiderivative. Now we've got to evaluate from negative 1 to 0. So we plug in. So we get sine of e to the 0 minus sine of e to the negative 1 And to be honest, you could just leave it right there. Or you could keep going a little bit. You could rewrite this as sine of 1, because e to the 0 is 1. Maybe minus sine of 1 over e. Another way to do it. But what's sine of 1? Could we simplify that? Without a calculator? Is that one of those unit circle angles?
I wish it wasn't, but at the same time, I think
Tim, your wishes have come true. It's not. It's not. Now, here are the angles that are nice unit circle angles. Sine of 0, sine of pi over 6, sine of pi over 4, sine of pi over 3, sine of pi over 2,
I get it now.
sine of 1. Now, inverse sine of 1, that's something you find right on the unit circle. But sine of 1, if the angle is 1, it's not a unit circle angle. So I was just messing with you. And then, and that's it. Leave it alone. All right, last one here out of these skill questions, number 8. We'll break out the calculator for number 9. So see if you can do it number 8 real quick. Ready, set, go. Oh, bad. You might have done this. And what I'm about to do, like right away, is not necessarily bad, but it would lead me to a bad place. I might say integral from 0 to 1 of e to the x. And I might go back to that thing of, hey, we really don't like fractions, and so let's make this not a fraction. And so I go 1 plus e to the x to the negative 1 dx. Now there's all kinds of not so pleasant things that could happen here. Are you watching? What I'm about to do is horribly wrong. I feel bad even writing this. We would never do that, right? It's just mathematically wrong. It's like saying 2 plus 4 is 24. It's not right. So then we look at this and we're like, well, gosh, hey, look, guys, the derivative of the inside is the other factor, right? Right? Timmy didn't mess up. But then we say this just goes back to the inside. And here's where you run into issues, because then you say 1 plus e to the x all to what power? Negative 1 plus 1 would give me 0 over, that's a problem. Just divided by 0, getting my that's not going to work. So I mentioned this before, I think it's worth mentioning again. If you find yourself dividing by 0 to find an antiderivative, you need to go back to one specific place. It's probably a natural log. So let's go back and say all this stuff, it was all well intentioned, but it's not going to work. I'm going to go back to this and ask myself, wait a minute, the derivative of the denominator is what?
Use the numerator.
It's the numerator. So not only is this a natural log, Timmy didn't even mess it up. It's set up beautifully for us. So since the derivative of the denominator is the numerator, right? Then all I have to do is say that the antiderivative is the natural log of the absolute value of the denominator. Right? The derivative of the denominator is the numerator, then that's your antiderivative. Evaluator from 0 to 1. So this would be ln of 1 plus e to the first minus ln of 1 plus e to the 0. So we could clean it up a little bit. It could be ln of 1 plus e minus ln of 2. Right? Because e to the 0 is just 1. 1 plus 1 is 2. Yeah.
Where did your absolute value signs go?
So I dropped them because 1 plus e is positive. Right? And 1 plus 1 is positive. They could still be there.
Makes sense.
I just chose, since I knew that those inputs were already positive, I didn't need them. It's not that I don't need them. Technically, I'm evaluating them in process. Yeah, you bet. Hey, guys, grab your calculators.